All right, we have a circle with 4 points on it, and those 4 points form a quadrilateral whose diagonals intersect at the center of the circle. I'm going to actually start with the diagonals. If the diagonals go through the center of the circle, that means that both of the diagonals have to be diameters. We'll call the center O. That means that we have our points A, B, C, and D, and we can connect them to make the quadrilateral, like this. Now, I'm going to claim here that quadrilateral ABCD is actually a rectangle. To prove that it's a rectangle, we need to show that all 4 of the angles are right angles, and we're going to use congruent triangles to do that. First, I want to notice that OA, OB, OC, and OD are all radii of this circle, so they have to be congruent. Also, I want to look at some angles. If we look at angle AOB, it has to be congruent to angle COD because they're vertical angles. Vertical angles are opposite angles that appear when 2 line segments intersect, and we know that vertical angles are equal to each other. The same thing is going to be true with angle AOD and angle BOC. They're vertical angles, so they're also congruent to each other. Now, if we look at triangle AOD, we can see that it's isosceles because 2 of its sides are the same. That means that the 2 base angles have to be congruent. And the same thing is going to be true with triangle BOC, and those angles have to be congruent not just to each other, but to the angles from AOD, because both of those triangles are isosceles triangles with the same vertex angle. We're going to see the same sort of situation appear in the other 2 triangles. If we look at triangle AOB, because it's isosceles, we know that the 2 base angles have to be congruent to each other. The same is true with triangle COD, but not only are they congruent to each other, but they're congruent to the 2 angles we just looked at in triangle AOB, because those 2 are isosceles triangles with the same vertex angle. We have 2 pairs of triangles that end up being congruent to each other. AOB and COD are congruent because they have 3 congruent angles and also at least 1 congruent side. Similarly, triangles AOD and triangles BOC are congruent to each other because they have 3 congruent angles and at least 1 congruent side. At this point, we can see that the quadrilateral ABCD must be a rectangle because all 4 of its angles are congruent to each other, and a quadrilateral that has 4 congruent angles has to have 4 right angles. That means that all of these are right angles, and ABCD is necessarily a rectangle, which is answer choice C. It's possible that it might also end up being a square, but it's not necessarily going to be a square. We know it's definitely going to be a rectangle, though.